Scene script. Have you ever wondered about the environmental impact of the cement that forms the backbone of our cities and infrastructure? Let's dive into it. Cement, the seemingly innocuous gray powder, is omnipresent. From the towering skyscrapers that punctuate our city skylines to the sprawling highways that connect us, it's a fundamental ingredient in modern construction. It's the glue that holds our concrete jungles together. But beneath its mundane facade, cement hides a startling truth. It's a silent yet significant contributor to global warming. Astonishingly, the production of cement accounts for around 8% of the world's carbon dioxide emissions. To put that into context, if cement were a country, it would be the third largest emitter of CO2 behind only China and the United States. So why does cement production emit so much carbon dioxide? It all starts with the manufacturing process. Cement is made primarily from limestone, which is heated in a kiln to over 1,400 degrees Celsius. This process, known as calcination, breaks down limestone into lime and carbon dioxide. The CO2 thus produced is released into our atmosphere, adding to the blanket of greenhouse gases that are warming our planet. Moreover, the high temperatures needed for this process demand a lot of energy, often derived from burning fossil fuels, which further contributes to CO2 emissions. In addition, the mining of raw materials for cement production leads to deforestation and habitat destruction, exacerbating the environmental impact. As we continue to urbanize and develop, the demand for cement is only going to rise. It's a catch-22 situation of sorts. On one hand, cement is indispensable for our infrastructure. On the other hand, its production is accelerating the climate crisis. Despite its utility, the environmental cost of cement is a problem we can no longer afford to ignore. As we forge ahead, it's crucial that we acknowledge this hidden cost and strive for more sustainable construction practices. It's not just about building for today, but ensuring a safer and healthier planet for future generations. The cement problem is a big one, but it's not insurmountable. It's high time we rolled up our sleeves and got to work on solving it. So, if cement is such a problem, what are the alternatives? Well, let's dive into some of the emerging and promising alternatives to traditional cement. These alternatives not only serve the same purpose as cement, but are also more environmentally friendly. First up, we have fly ash. This is a byproduct of coal-fired power plants that's often just treated as waste. However, it can actually be used to produce a type of cement that's every bit as strong as the traditional stuff. The beauty of fly ash is that it's a waste product, so by using it, we're not just reducing our need for traditional cement, we're also finding a productive use for something that would otherwise be discarded. Next on our list is slag cement. Slag is a byproduct of the steelmaking process. Again, something that's often just thrown away. But when it's ground up and mixed with other ingredients, it can actually make a pretty good cement substitute. And like fly ash, using slag cement not only reduces our reliance on traditional cement, but also helps us find a use for industrial waste. Then we have calcined clays. These are a type of clay that's been heated to a high temperature to change its properties. The resulting material can then be used to make a type of cement that's lower in carbon emissions than traditional cement. This is particularly promising because clays are abundant and widely available across the globe. However, it's important to remember that these alternatives are not a silver bullet. They're part of the solution, but they're not the whole solution. To truly tackle the environmental impact of cement, we need to look at a range of strategies, from reducing our use of cement to improving its production methods and finding alternatives. These alternatives offer a promising path to reducing the environmental impact of construction, but they are not a silver bullet. Can we make cement production more sustainable without giving up on cement entirely? This is the question that has been driving innovation in the industry. Imagine a world where we can have our concrete cake and eat it too, figuratively, of course. One promising development is the advent of carbon capture and storage technologies. These systems do exactly what their name suggests. They capture the carbon dioxide emissions produced during cement manufacture and store them safely underground. The beauty of this approach is that it tackles the problem at its source, preventing the harmful gas from ever reaching our atmosphere. This could significantly reduce the carbon footprint of cement production, but that's not all. There are other innovations aimed at making the process more energy efficient. For instance, some companies are exploring the use of alternative fuels like biomass or waste-derived fuels to power their cement kilns. Others are experimenting with new types of kiln designs that require less heat. These solutions could dramatically cut down on the energy required to produce cement, thereby reducing its environmental impact. And then, there's the exciting world of biocement. This is a cutting-edge approach that involves using bacteria to produce cement. Yes, you heard that right. Bacteria. These tiny organisms can be engineered to produce a cement-like substance, potentially offering a more sustainable alternative to traditional methods. There's also a flurry of research happening around geopolymers, a type of binder that can be used in place of cement. They are produced at lower temperatures and thus result in significantly less carbon dioxide emissions. However, innovation doesn't come without its challenges. While these technologies hold great promise, their widespread adoption is hindered by technological and economic hurdles. Carbon capture and storage, for example, is still a nascent technology with high implementation costs. Biocement and geopolymers, on the other hand, are still in the research stage, and it might take some time before they are ready for commercial use. These innovations, though promising, are not yet widely adopted due to technological and economic challenges. But with continued research and investment, we can hope to pave the way towards a more sustainable future of cement production. The environmental impact of cement production is a serious problem, but there are solutions. We've delved into the hidden cost of cement, unearthing the stark environmental impact that traditional cement production has on our planet. It's a problem far too big to ignore, and it's high time we took it head-on. We've also explored the potential of alternative materials. From geopolymers to hempcrete, these alternatives offer promising ways to reduce the carbon footprint of construction. But it's not just about finding new materials. We also need to improve the old ones. Innovations in cement production are paving the way for this. Techniques like carbon capture and storage and the use of waste materials in production are just some examples of how we can make traditional cement greener. To truly address this issue, we need a combined approach. We need to embrace both alternative materials and improve traditional cement production. To make a real difference, we need concerted effort from industry, governments, and consumers. Every step we take towards greener construction is a step towards a sustainable future.